Welcome to The Explainer. Today, we're tackling a concept that's, well, everywhere. From election polls to medical breakthroughs, it's called probability sampling. And it's basically the science of knowing a lot by only looking at a little.
And it really all boils down to a question you've probably asked in your own kitchen. You're making spaghetti. How do you know when it's ready? You don't eat the whole pot, right? Of course not. You grab one noodle. That one little noodle, that simple idea is pretty much the key to this huge concept in statistics.
So let's blow this up. Imagine you're not a chef, but a researcher. You want to know what all the voters in a country are thinking, or maybe all the users of your app. You can't talk to every single one of them. It's just impossible. So what do? Well, just like with the spaghetti, you take a small piece, a sample, to get a sense of the whole picture. But, and this is a big but, how you pick that sample, that's where things get really interesting.
Okay, so let's just lock in a couple of key terms here. The population, that's the entire pot of spaghetti. It's every single person or thing you want to know about. And the sample? Well, that's the noodle you actually taste, the small specific group you get your data from. And trust me, getting this right is absolutely critical, because if you grab the wrong noodle, your conclusions about the whole pot are going to be way, way off.
And when sampling goes wrong, oh boy, it can go spectacularly wrong. The results can be just completely misleading. Let's look at a perfect real-world example of this from back in 2014, during the Scottish independence referendum. An early poll came out with this huge, dramatic claim, but it was based on a seriously flawed sample.
The headlines were everywhere, and they were bold. They claimed that young people were voting in droves for independence, something like 71% of them. It looked like this was a massive generational thing, the youth driving this huge political shift. But here's the kicker. The entire sample of young voters that this gigantic claim was built on was just 14 teenagers. Yep, 14. That's it. They used just 14 people to speak for an entire generation.
So, no surprise, a later poll, a much bigger, better one, found the complete opposite was true. In reality, a majority of young voters had actually voted no. So you see, the problem with that first poll wasn't just that it was tiny. The real problem was this hidden villain lurking in the background, something we call sampling bias.
So what is this sampling bias anyway? Well, think of it as a thumb on the scale. It's a systematic error that happens when your method for picking people isn't fair. It favors certain types of people over others. So your sample is kind of skewed from the very beginning, which means, of course, your results are going to be skewed too.
Okay, so how do we fight this villain? How do we make sure that the one noodle we pick actually tells us the truth about the whole pot? Well, the hero of our story is a very simple but incredibly powerful idea: randomness.
And this brings us to the core of it all: probability sampling. This is the gold standard, the golden rule. It's a research technique where every single member of the population has a known, non-zero chance of being selected. It's not about convenience, it's about fairness. It's like giving every single noodle in that pot an equal shot at being the one you pick. No favorites.
And that is exactly why this is the gold standard in research. It ensures your sample is a mini version of the whole population. It slashes that sampling bias we were talking about. And it means you can actually generalize your findings. What you learned from the sample, you can confidently say is likely true for the whole group. This is the foundation, the very bedrock of any research you can actually trust.
Okay, so you're probably thinking, how do they actually do this? How do researchers get this pure randomness? Well, they have a whole toolkit of methods. It's not just, grabbing people off the street. It's a very structured, very deliberate process designed to guarantee fairness.
All right, let's start with the most straightforward one: simple random sampling. It's pretty much exactly what it sounds like. First, you figure out your whole population, say all 5,000 of your customers. Then you make a list of every single one of them. And finally, use some kind of random method like a lottery or a computer program to pick people. It's literally the scientific version of drawing names out of a hat.
Now, drawing names from a hat is great, but what if your population has important subgroups in it? Like, what if you need to make sure you have the right mix of different age groups or people from different cities? You can't just leave that to chance. And for that, we've got some more advanced, more targeted techniques.
Two of the big ones here are stratified sampling and cluster sampling. They sound kind of similar, but the difference is huge. With stratified sampling, you slice your population into important groups. We call them strata. And then you do a simple random sample from each group. But with cluster sampling, you again divide the population into groups, clusters this time, but then you randomly pick a few entire groups to survey. See the difference? Sampling from the groups versus sampling the whole group.
And this table really highlights the trade-offs researchers are always making. Stratified sampling? That gives you amazing precision. You guarantee every key group is represented fairly. But it's a lot more work, and it costs more. Cluster sampling, on the other hand, is way more efficient. It's cheaper, it's faster, especially if your population is spread all over the country. The trade-off? It's usually a little less precise.
So we've seen the right way to do this, the gold standard. Now, let's talk about the opposite, the easy way, the common trap that so many fall into, which is the unreliable cousin of probability sampling.
It's called convenience sampling. And yeah, it's exactly what it sounds like. It's when you pick people just because they're, well, convenient. Think about surveying shoppers at the mall, or the students in your one college class, or just polling your followers online. It's super quick, it's cheap, but oh, there is a massive catch.
Because there's zero randomness involved, that sample is almost guaranteed not to represent the wider population. The results you get? They only tell you about the people who happen to be at that mall on that day, or the people in that specific class. That's it. You can't generalize it to anyone else, which means the findings have very, very little credibility.
So here it is, the final showdown. On one side, you've got probability sampling. It's based on randomness, it has a low risk of bias, and you can generalize the results. It's the cornerstone of reliable research. On the other side, you've got non-probability sampling. Based on convenience, super high risk of bias, and you absolutely cannot generalize the results. To go back to our kitchen, it's the difference between knowing if the whole pot is ready versus just knowing about the 1 or 2 noodles that were easiest to grab.
So, okay, why does any of this matter to you? I mean, really? Well, because we are swimming in a world of data, polls, and studies. And being able to spot the difference we just talked about, it's like having a secret superpower.
Because now you have the tools to be skeptical in a smart way. You can question those flashy news headlines based on a poll. You can evaluate claims from market research. You can spot those totally unreliable studies that pop up on social media. You become a much sharper, much more critical consumer of information. At the end of the day, you have to remember this. Data without context is pretty much meaningless, and it can be incredibly misleading. And the number one most important piece of context you need for any poll or survey is its sampling method. How did they choose their people? That context is everything.
Thanks so much for joining us. Now, the next time you see a statistic, a poll, any piece of data claiming to represent a big group of people, you'll know the most powerful question you can possibly ask.